Have you ever wondered what lies beyond our known universe? This is a question that has been asked by philosophers, scientists, and curious minds alike for centuries. Let's start by painting a picture of the enormity of our universe. To get a sense of scale, if our solar system were the size of a coin, the Milky Way galaxy would be about the size of North America. And within this immense galaxy, there are about 200 billion stars, each with their own unique set of planets. Now take a moment to let that sink in, and then consider this. The Milky Way is just one of over 2 trillion galaxies in the observable universe. Imagine for a moment that you were able to travel from one end of the observable universe to the other. It would take you about 93 billion light-years. That's a journey that light, the fastest thing we know of, would take 93 billion years to complete. But what's beyond that? Could the universe be infinite? This is where things get really interesting. According to some theories, the universe doesn't have an edge or a center, it just goes on and on, without end. This is the concept of the infinite universe. If the universe is indeed infinite, it implies that there could be an infinite number of galaxies, stars, and planets out there. That's a mind-boggling thought, isn't it? But it doesn't stop there. An infinite universe could also mean that there are an infinite number of possibilities. There could be countless versions of Earth and perhaps even countless versions of you and me, each living out different versions of reality. The implications of this concept are profound and can change our understanding of the universe and our place in it. The vastness of the universe is humbling, isn't it? But wait, there's more. So we discussed the infinite universe, but did you know that 95% of the universe is made up of stuff we cannot see or touch? That's right. We're diving into the enigmatic world of dark matter and dark energy, the invisible actors of our cosmos. Let's start with dark matter. It's like the shy kid at the cosmic party, never interacting with anything but constantly influencing the scene. We can't directly observe dark matter because it doesn't emit or absorb light. So, how did we even come to know about its existence? It's a bit like feeling the wind on your face. You can't see it, but you can certainly feel its effects. In the case of dark matter, scientists observed that galaxies were spinning way too fast according to the laws of gravity. So fast, in fact, that they should tear themselves apart. But that's not happening, is it? The galaxies stay intact, and the reason it turns out is dark matter. Its gravitational effects hold the galaxies together, like an invisible cosmic glue. Moving on to dark energy, it's the mysterious force that's causing our universe to expand at an accelerating rate. It's a bit like blowing up a balloon, but instead of your breath, it's dark energy that's pushing the universe's boundaries. Now you might be thinking, great, we figured it all out then. Well, not quite. Despite the progress, there's still so much we don't know. There are theories, of course. Some suggest dark matter is made of undiscovered particles, others propose modifications to the laws of gravity. As for dark energy, it's even more elusive. Some theories point to the vacuum of space itself producing energy, while others suggest it's a new, unknown form of energy. The research is ongoing, and every day scientists are peering into the darkness, hoping to shed light on these cosmic mysteries. Who knows what startling revelations await us in the unseen corners of our universe? Imagine that most of the universe is unseen, like a cosmic ghost. You might have heard that nothing can travel faster than light, but what does that really mean? Let's dive into the world of photons and parsecs to unravel the enigma that is the speed of light. When we talk about the speed of light, we're discussing a cosmic speed limit, a fundamental constant of nature clocking in at a whopping 186,000 miles per second. That's like traveling around the Earth 7.5 times in a single second. Imagine that for your next vacation. Now, the speed of light isn't just a fun fact to impress your friends. It's a cornerstone of our understanding of the universe. Because light takes time to travel, when we look at the stars, we're essentially peering into the past. The light from a star 10 light-years away, for instance, started its journey 10 years ago. So, we're not seeing the star as it is now, but as it was a decade ago. This concept of light years is crucial in grasping the sheer size of the universe. A light year is the distance light travels in a year, about 6 trillion miles. So when we say a galaxy is 1,000,000 light years away, we mean the light we're seeing from that galaxy today actually left there 1,000,000 years ago. Mind-boggling, isn't it? Let's add another layer of complexity. Time dilation. This is the idea that time moves differently depending on how fast you're moving. According to Einstein's theory of relativity, if you were able to travel close to the speed of light, time would slow down for you relative to someone who is stationary. This means you could theoretically return from a high-speed space trip to find everyone you know significantly older or even long gone. It's a bit of a downer, but don't worry, we're far from making such trips a reality. So remember, next time you're late, blame it on the speed of light. After all, we're all just trying to keep up with the cosmic speed limit. Think space is filled with all sorts of alien noise, think again. In reality, space is an incredibly silent place. You might be asking, how is that possible? Well, the answer lies in the nature of sound and space itself. Sound needs a medium to travel through, like air, water, or metal. But space, my friends, is a vacuum. It's almost entirely empty, with no air or atmosphere for sound to bounce off. So, let's say you're out there, floating in the great cosmic void, and a nearby star goes supernova. Despite the massive explosion, you wouldn't hear a thing, not a bang, not a whisper, not even the faintest pop. Your eardrums would wait in vain for a sound that will never come. But wait, you might be thinking, how do astronauts communicate if there's no sound in space? That's a fantastic question. Astronauts use radios to communicate. Radio waves can travel through the vacuum of space, reaching astronauts' headsets and translating into sound. So, while space might be silent, the chatter of astronauts and mission control fills the void. And what about the beautiful symphony of space we often hear in documentaries and movies? Well, that's not exactly the sound of space either. Scientists use specially designed instruments to detect electromagnetic vibrations from celestial bodies and phenomena. They then convert these vibrations into sound waves that we can hear. So, when you listen to the hauntingly beautiful sounds of Jupiter's storms or the rhythmic pulsing of a distant pulsar, you're actually hearing a kind of translation, a human interpretation of the silent language of the cosmos. So, the next time you gaze up at the stars, remember, space is not the noisy, alien-filled frontier you might have imagined. It's a silent ballet of planets, stars, and galaxies, dancing to a tune that can only be heard with human ingenuity. So if you're planning a trip to space, don't forget your radio. Last but not least, the biggest question of all, are we alone in the universe? As we turn our gaze upon the twinkling stars, we can't help but ponder about the possibility of life beyond our own celestial home. The cosmos teems with countless stars, each potentially orbited by planets. Given the vast number of these celestial bodies, it's hard to shake off the thought that we might not be the only life forms in this grand cosmic theater. The ongoing search for extraterrestrial life is a thrilling saga that spans decades. Our exploration is driven by curiosity, a thirst for knowledge, and the innate human desire to understand our place in the universe. We've sent rovers to Mars, probes to the distant corners of our solar system, and even messages to the stars, all in the hope of finding a sign, a hint of life that is not our own. But what does it take for life to exist as we know it? It's not as simple as finding a planet with water. Life requires a delicate balance of conditions. A planet must be in the Goldilocks zone, not too close nor too far from its star, where conditions are just right for liquid water to exist. It needs the right chemical elements, and a stable environment that can support life for billions of years, allowing evolution to shape complex organisms from simple life forms. Yet, given the sheer number of planets, the idea of life existing somewhere else in the universe is not only plausible but highly probable. There are an estimated 2 trillion galaxies in the observable universe, each teeming with billions of stars and countless planets. With such mind-boggling numbers, the cosmos may be more alive than we've ever imagined. So are we alone? Only time and space will tell. Our quest to answer this question continues to drive us, as we explore the vast, awe-inspiring expanse of our universe. This grand cosmic adventure is just beginning, and we are the pioneers, daring to seek the answers in the stars.